Welcome back to Educator.com, and thank you for joining us for Linear Algebra. Today we're going to be discussing solutions of linear systems, part 2. Okay, let's go ahead and get started. We closed off the last session by converting the following matrix, and you'll remember, of course, sometimes I actually leave off the little brackets on the side of the matrices simply because it's a personal notational preference, that's all, as long as you understand which grouping of numbers goes together. Okay. We had 1, 2, 3, 9, 2, negative 1, 1, 8, and 3, 0, negative 1, 3, and we converted that to reduced row echelon form to 1, 0, 0, 2, 0, 1, 0, negative 1, and 0, 0, 1, 3. And notice the reduced row echelon form, it has 1 as leading entries, and wherever the row has a 1 that is a leading entry, everything else in that column is a 0. This column, of course, doesn't matter because it's the third row here, so it is irrelevant as far as the definition of reduced row echelon is concerned. Okay, now we did that just for matrices. Well, we already know that a given matrix represents a linear system of equations. So this system looks like this in terms of the variables. X plus 2y plus 3z equals 9. Notice x plus 2y plus 3z equals 9. And then 2x minus y plus z equals 8. And then 3x plus 0y. You don't necessarily have to put this there. I like to put it there simply because for me it keeps things in order, in line, and it just keeps things consistent. Minus z is equal to 3. And again, what we've done is whenever we transform a matrix from the standard matrix to its reduced row echelon form, we form an equivalent system. So what we've produced is the following. This time I'm going to actually avoid the zeros. We have x equals 2, y equals negative 1, and z equals 3. So this is our solution. Matrix represents the linear system, converted to reduced row echelon form. We get, that's one of the reasons why we like these 1s in these positions and zeros everywhere else, is because it just gives you the answer. X is one thing, y is another, and z is another. Okay. And in this particular case, we have a solution, so it is a unique solution. For this particular system, for this particular system, there is no other. It is unique. Okay.